Intermolecular Forces Notes Lecture. Intermolecular forces, or IMFs, are defined as forces that result from many different attractions and repulsions between molecules, which is why they are intermolecular forces. IMFs exist because electron density differences inside of the molecule itself exist. These electrons of each individual atom move around and create spaces of high density and spaces of low density inside the molecule. IMFs are similar to magnetic forces, and therefore magnets. They are positive and negative attractions between molecules. Intramolecular forces, not to be confused with inter, are the bonds between atoms in a molecule. These are much, much stronger than intermolecular forces. Dipoles and bond dipoles. Remember, electrons have a negative charge, while dipoles are permanent positive and negative ends of a molecule, similar to a magnet. These happen because some atoms attract electrons to them better than others. Electronegativity. Bond dipoles are dipoles inside the actual bonds between atoms. These also happen due to electronegativity, and some atoms attract electrons better than others. There are three different types of bond polarities that are based on the electronegativity difference of atoms. An ionic bond is made up of 2.0 difference or greater. Usually this is between a metal and a group 16 or 17 element. A polar covalent bond occurs where electronegativity is between 1.9 and 0.7 difference. Usually between two nonmetals, not close together on the periodic table. These are the types of bonds that usually make dipole-dipole interactions and hydrogen bonds possible. Nonpolar covalent bonds are made up of less than a 0.7 difference in electronegativity, usually two nonmetals close together on the periodic table. These will usually lead to London dispersion forces. Bond dipoles are labeled on a drawn structure of a molecule. These atoms that make up the molecule attract electrons to them differently and have electrons either further or closer to them to create the poles. The Greek letter lambda indicates the two sides of the dipole, while lambda positive or plus indicates the positive side of the dipole, and lambda negative or minus indicates the negative side. The negative pole will usually be the one with the higher electronegativity. These interactions go on indefinitely and keep a substance together. In this example, hydrochloride, chloride has a higher electronegativity, so it has a negative pole in the dipole. We will be looking at dipole-dipole forces. Dipole-dipole forces are the positive-negative attractions between two different molecules when each have a dipole. Similar to positive and negative attractions in magnets, the atom with the higher electronegativity brings the bond electrons closer to it, making it a negative pole, while the other one is positive. These interactions are what keep substances together. Dipole-dipole forces are the second strongest type of intermolecular forces. Dipole-dipole forces can be made stronger by having a larger electronegativity difference between atoms. You can see here that chloride, having a greater electronegativity than hydrogen, attracts the hydrogen. Hydrogen bonds. Hydrogen bonds are a special type of dipole-dipole interaction. It is reliant on the fact that hydrogen only has one electron, so then when it makes a bond, no other electrons are around its nucleus, and its nucleus is then attracted to electrons on other nearby molecules. Hydrogen bonds only happen in molecules that have a hydrogen, then oxygen, nitrogen, or fluorine. These are the strongest IMF we will look at, but they're still weaker than intramolecular forces. In the image, you can see that the hydrogen on the right water molecule is attracted to the oxygen's electrons in the left-hand molecule. Temporary dipoles and London dispersion forces. A temporary dipole is a very short period of time where a molecule's electrons all move to mostly one side or the other and create a situation where one positive and negative pole, like a dipole, occurs. These happen in molecules that don't have dipoles due to an electronegativity difference. London dispersion forces, or LDFs, are the attractive force that results from these temporary dipoles. These are the weakest IMFs, and mostly are present in substances that have nonpolar covalent bond dipoles. LDFs can be strengthened by being a larger molecule. A large molecule has more electrons, which helps make the temporary dipole stronger.